Hello everyone, so this is the first video for first lecture for building electrical system. Like for this class, we will only focus on two topics of electricity. The first one, fundamentals like basic properties for electricity and power distribution and voltage drop. For each of the topic, we will have a homework to support your understanding. And for the electrical material, lighting system estimating, I don't want to input too much. So because we already have too much knowledge in this class. So for you, I hope you got the big picture like fundamentals, power distribution, and voltage drop. So let's start today's class. First one, let's record some basic properties of electricity. So what is electrical power? There's P we introduced in the first lecture in this class. So unit is watt or kilowatt, W or kW. And the quantity of electricity, usually simple as Q, and this basis of electricity of course energy. So electrical energy, like you also want to pay an electrical bill, so you may see the quantity of electricity. The unit is WH or kWh. And the current I is the flow of electricity in an electrical circuit. So the unit of current is ampere. A. Smaller, we use MA or macro A. And the voltage, V or E, is the electromotive force or potential difference that causes electrical current to flow. The unit of voltage is volt. Resistance is an internal property of matter that resists the flow of electrical current. The unit is ohm. So here I provide a summary of the quantity and unit. You can just record this information. Current I, unit is A. Voltage symbol is E or V, unit is V, volt. Resistance symbol is R, and unit is ohm. So here is basic information, and then let's see some equation or formulas. You have to know they're very important in this class, like you design electrical system and also you want to calculate electrical bill, so you have to know that. Like first one, ohm law, E is I multiply R. So E I R. So E is I multiply R. Top is bottom multiply. And also watt law, P power is current multiply voltage. So you have to remember both of the formulas. They are very important in the remaining of the class. And here I list the other electrical fundamentals, so you can find a lot of formulas. They are convert depending on the both of the two. So EIR, PIE, and also you can convert to the other types. But by the way, just remember both of the two. Got it? You can convert to the others. So now let's start some new knowledge for today's class. You have to know for the building electrical system, like what is conductor and insulator. So it's depending on the resistance. Resistance is R. We use ohm to measure that. So right here. Okay. So right here, low resistance is mean low R. And also we can assume a higher current goes through the circuit. And a high resistance, this means high R, this means low current. So we call this an insulator. So make sure you know what's a conductor and insulator. Usually in the simple circuit, let's see, a simple circuit is a battery. This is electrical source, and load is maybe light lamp, and we have a switch right here connected. So this is wires. Okay, this conductor. Okay, so to carry current goes through in this circuit. And what is a closed circuit? A circuit is a closed loop to accommodate electrical flow. So we close the switch, the current carry through the wires. So this is a closed loop, it's a closed circuit. If we open the switch, there's an absence of a continuity, indicate open circuit. That means no zero current goes through the circuit. So right here, so what's the detail for closed loop circuit? So closed loop circuit contains voltage source like battery, load like lamp or some other equipment, and a conductor to carry current. Usually it's electrical wires, and usually has a switching device to turn current on and off. And circuit breaker. What is circuit breaker? It's a switch that trip open when the current amperage exceeds the breaker rating. It is safety design. We have to provide for the all like apartment unit, for the all building, residential building, commercial building. You have to provide the circuit breaker. Like especially at the same time, you open all equipment like dishwasher, laundry, and you use a lot of PCs, like other heavy machine. So that's mean that at the same time, too much current goes through in the circuit. So the wire cannot carry enough current. That means have the safety issue. Okay, so circuit breaker can avoid this issue. We have to consider, and especially ongoing construction project, we have to use a temporary wiring system. So maybe we have to consider the circuit breaker to install in the temporary power system. And then let's see some simple circuit. So battery, we can assume this electrical battery and the lamp. So this is open circuit, open loop. The switch is open, so current is 0. And if the switch is closed, so the lamp is up, and then so how much current goes through in the circuit? So we can use I is P by E, divide E. So 50W, 120V. So usually in US the especially for the residential building, most of the equipment we use 120V or 240V. Okay, but like in China, like in my country, we use 220V. That it's different for the different country. We have the different voltage standards. So, but in the US, we always use 120. Most of the time, we use 120. And the category of electrical circuit, so that's very important. And here lists the 3 types of the circuit. Most of the time, like residential building, commercial building, we use all of the 3. Let's see what's a series circuit. Series circuit provide a single path for current flow. So like in the office, like some multiple lamps, we use one switch to control. Like now we assume here have the switch. We can use this switch close the 2 lamp up. If we open 2 lamp close, right? So this a circuit will equal current flow through all electrical loads. So how about the series circuit? IT. Okay, I total, current total, I1, I2. So what happened here? Current equal current flow through all electrical load. And how about a parallel circuit? Each load is connected directly to voltage source. You can find like this one. Goes through, the current goes through. And that's one, current goes through. So the 2 individual load, each load directly connect to the electrical source. So what happened in the parallel circuit? Voltage total, this one, E1, E2. So we can assume ET same as E1 same as E2. Okay, and also IT, I1 plus I2. This is a parallel circuit. And for the series parallel circuit, this combine series and parallel circuit. Okay, this consists of both a series and a parallel design. Like a office building or classroom, you can use 2 switch to control all lamps. Like one switch control maybe 4 lamps, one switch control the other 4. So for the one switch control 4 lamps, this is a series circuit. And the 2 switches to control total 8, it should be series parallel circuit because it's combined series and 2 parallel circuits. So this is series parallel circuit that are very, very common in especially like office and big building like commercial building. Like in the residential, usually most of the time, like one lamp use one switch to control, or 2 lamp use one switch to control. This is series. And the other room, maybe we have the other switch, we use an other circuit. So there's a 2 series circuit. But for the big room, like classroom, we have too many lamps. Maybe at that time we have to use series and parallel circuit, use multiple switches to control many lamps. And then let's see some very common convenience receptacle. So here I list some typical receptacle for residential, commercial, and hospital. And this one, only this one is special. Only this one is special, GFCI. This one is ground fault circuit interrupter. So like if you want to use the receptacle in that environment like bathroom, restroom, and kitchen, you have to use this one. This is a safety design. And also it's very common in the bathroom in hotel. Most of the time you want to use a hair dryer, so you may find you have to use a GFCI receptacle to get power. And then let's see some electrical power to convert to the other energy. Do you remember the first class I introduced 4 types of the energy, like electrical energy, thermal energy, like when we introduced HVAC, so we always calculate the thermal energy. Other one is mechanical energy, like use scooter. If you are using scooter, so scooter use electricity, and then you can drive from your home to school, so that's mechanical energy. And the other one is chemical energy. So let's say in a building, in a home, so most of the time what is electrical power to use, like for this one, like in the morning, most of the time we use that. It's electricity into heat energy. We get the hot food. And this one blender or mixer. So there's electrical energy into mechanical energy. And also maybe we have to consider plus the heat energy. Okay, because like several minutes, if it starts several minutes, you can find the temperature increase. You touch the blender, you'll find the temperature increase. So plus mechanical and heat energy. And then let's say some calculation, because we introduced, like, let's recall. So E is I multiply R, and P is I multiply E. So let's see the series circuit. So do you remember series circuit? IT is I1, same as I2, right? And let's see, giving information, P1 is 1, 2, 3, 0. I2 is 5, 8, right? And E total is 120, because right here electrical source is 120. So IT is the same as I1, I2. So we know it's okay. So we already know P1. So what we can got? We can got E1. P1 divide I1. Okay. Blue. We can got E1. And then we already know ET. Total is 120. So E2, maybe we can use this method, minus E1. And also, how about the P2? So P2 is I2 multiply E2, because we got E2 right here. I2 is 11.5, so you can get a P2. So use the 2 laws to convert a lot of different formulas to get your expected outcome. And the current is same, okay? Current is same, you see? IT same as I1 and same as I2. And then let's say parallel circuit. So given information, let's again to see given information. ET is 120V. P1 is 1230W. I2 is 11.58. So parallel circuit, ET, so voltage is same. Okay, E1 same as E2. And then let's say what we can calculate. We can calculate maybe P2. We can calculate P2. P2 is I2 multiply E2, so 11.58 multiply 120B, right? So we can get a P2, and anything else we can calculate. We can calculate. Can we calculate I1? Yes, we can calculate I1, so P1 multiply E1, because we already know that, right? W minus 120V, we can get I1. So can we get I total? Yes, I1 plus I2, okay? It's a parallel circuit. Voltage is same. And right here, I put the exact number and answer, so you can find it. You can calculate by yourself like this, and then to see the answer. And some samples from the real world equipment. Let's see this one, very common, right? So if you want to see that, you can just look for the table on like your home equipment. You can find this, like 120V, this voltage, 900W is P, so you can get I, P divided E. And like this one, kitchen ad, I don't know what's the exact equipment, but this is very common, okay? And 120V volt, and then you can know that it's for this I current, so you can get the P. And do you remember what is HP? It's horsepower. So here is a example horsepower. So this one is constant, okay, constant number. So always you can use it to convert HP. Use a P to HP. You can use this constant number to calculate. And then let's see some new terminology. Direct current. Do you know what direct current? Actually, we have the other type current, but I will introduce later. But for this class, there's a basic information. Let's just focus on the direct current. Like most of the time, like inside of the building, we use electricity that belong to direct current. Like you PC, you charge phone, you want to get a lamp light up. So we always use a direct current. So direct current is a constant flow of electricity through a conductor in one direction. Dry cell battery connected to a light bulb is an example of a simple DC circuit. There's a direct current in the home most of the time, like in the home. Like we can directly touch some equipment they are using DC. Okay, let's say DC series circuit. Actually, we already introduced some relationship among like voltage, power, current, and resistance. Here is a summary. Like for the DC series circuit, voltage is sum of the voltage across each load, like ET is E1 plus E2 plus E3. And current is same in all part the circuit. IT is I1 same as I2, same as I3, okay? And the total resistance is sum of the individual load resistance. RT is R1 plus R2 plus R3. And total power, PT is P1 plus P2 plus P3. This for series circuit. And how about for parallel? Parallel is voltage across each load is same. So ET same as E1, same as E2, same as E3. And total current is sum of the current in each load. IT is I1 plus I2 plus I3. And total resistance is always lower than more as the load resistance. What's mean of that? I will show later. Okay, so total resistance always lower than smallest load resistance. That means the total resistance smaller, less than this, less than this, less than this. And total power is so it's same as series P1 plus P2 plus P3. So let's see how about parallel circuit total resistance, like this one. This is series circuit, so R total is just a plus all of the resistance. And for the parallel circuit, R total receptacle is R1 receptacle, R2 receptacle, R3 receptacle. So RT, R1 plus R2 plus R3 plus blah 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 blah. Okay. So this is a difference for resistance. And then let's say the calculation. So what are rules? So IT, so this is series, right? RT, current the same for the all parts. Voltage is sum of the voltage, power is sum of the power. So let's find IT and RT. So IT is PT, ET, okay. PT plus 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 10 plus 60 plus 60, right? ET plus 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 110 plus 10. We got the IT. So how about RT? ET divide IT. Okay, so you can get the RT resistance T. And then how about the parallel? Parallel RT. R1, R2. Okay. Am I correct? Yes. Okay. And then how about I1? I1 is 100 V 56 ohm. Okay, because ET same as E1, same as E2. And how about I2? 120 V 100 ohm. This I2. Okay. And IT, how about IT? IT is I1 plus I2. Okay, make sure you know the relationship among them. Here I list the detailed answer, so just check. I hope you can try by yourself and stop here and then to check answer. And then let's introduce homework. So how to adjust the homework? This is a series of parallel circuit. And then let's see given information. Given information, T is 120 V, and P1 is 60, P2 is 100 W. Okay, and then let's see what we need to do. So first one, calculate the current in each load. So I1, I2. This is given information. Okay, given. And then let's answer. I1. What is I1? So parallel circuit, ET same as E1 same as E2, right? So I1 should be E1. Oh, sorry. Should be P1 divide E1. P1 is 60. E1 is 120. Okay, you can calculate. And how about I2? P2, E2. P2 is 100. E2. Okay, got it. And the next question, total current. Total current is I1 plus I2. Resistance of each load, R1. E1, I1. Okay. What is E1? 120 V, right? I1 you calculate right here. 0.5. How about R2? E2, I2. This one, you got it from here, okay? I don't want to calculate because it's homework. I just letting you know the method. And then total resistance. This is parallel. Okay. And then total energy consumed in a year of each load. So you have to calculate water or kilowatt, okay, or okay. So how to do that? Power, total power. Like we know the first lamp is 5 hours per day, so 65 days per year. So this should be P1 plus 5 plus, right? You can get how much W, and then you have to convert to kW. Do you know how to convert? 1000 W is 1 kW. Okay, you have to convert to kW. Why? Because unit cost is kWh. Okay. Oh, that's H. This H, because P is W, and then when we consider the hour time, we have to convert to quantity of the electricity. Okay, this is a quantity of electricity. This WH or kWh, and then finally you got the Q1, Q2, P2 plus 8 multiply 8 multiply 5. You got the kWh, Q1. So finally Q1 plus Q2, and then multiply 0 kWh. You can get final answer for the cost of the electrical energy for each load for the this is for total total. You have to Q1, Q2. Okay, it's for each of them. And then there's a homework method, so make sure review the slides together. So just the two things you need to know: one, what's a parallel, what's a series, and what's a relationship of the PIRE. What's a relationship of them for series and parallel, and then you can get it. So next section is for the lighting system. Like again, like in this class, I don't want to introduce too much for electricity, just to give you the best information for electricity and let you know what is a power system and voltage drop. Just to get the big picture for electrical system. So right here, just a relax part. So I just want to introduce part of the lighting system. If you are architecture students, you may be more familiar with it. So good lighting will create a visual environment that enables people to see, to move, and to perform visual tasks efficiently and safely without causing undue visual fatigue and discomfort. So let's introduce lighting, very important. And also, like for the homework, we are calculate the total cost for lighting energy, right? So why lighting energy is very important. In home and office, from 20 to 50% of the total energy consumed is due to lighting. Lighting accounts for 20% of the all electrical energy use, and lighting accounts for about 5 to 10% of the total energy use. So actually for a building, like especially residential building and commercial building, the two types of the energy consumption. The first one is HVAC, the second one is lighting. So if you want to design sustainable lighting, you have to consider two things: energy conservation and energy efficiency. Especially we have to make sure energy saving in lighting energy use, and also we have to consider the lighting design is comfortable for us, like no glare, no very high radiant, like the nature lighting radiant, because we have to consider some energy, and also Like we have to make sure the lighting can make the enough work productivity. So daylighting architecture, we use natural light to illuminate building space. Like we use some opening windows and reflective surface, uh, especially to make sure we can get enough natural lighting to provide effective internal lighting. And what's the benefit of the natural lighting? Reduce energy consumption and also provide high quality lighting, because artificial lighting, the best artificial lighting is stimulate natural lighting and increase the business productivity. Like for the all office, if we want to get a really good design, we have to consider for the all space, all room to provide natural lighting. And source of the daylighting, they include directly sunlight and diffuse light from the sky after it has been reflected by the gases and water droplet in the atmosphere, and the reflected light from clouds, ground planes, surrounding buildings, and landscape feature. Daylighting factor DF, this is a ratio expressed as a percentage of the illumination outdoors to indoor on an overcast day. Like if you want to design a lead project, you have to calculate what is a daylight factor in this building or in this room. For the different type of the building or room, they have the different daylight factor. And then you want to get the credit in the lead project, or you want to get the energy efficiency evaluation assessment. So you have to use daylight factor to do some calculation. And sky cover, so for the different area, they have the sky cover that different. Like for the California, maybe they have the more direct sunlight, but for the northern of the US, especially like Chicago, so sky cover is more than California. So when you are design the opening windows, you have to consider this. And also you have to, like you are design the interior design, like curtain, the shading device, so you also need to consider sky cover. And daylighting design factor, so some of features in fact daylighting design, like location, climate, building form, building orientation, layout of interior element, space, and material. So let's one by one to quickly go through what's that. Location and orientation. So orientation, that's like US is northern of the earth, so that's mean the source face, they are facing more natural light. Like in this wall, they are facing more lighting. Like if you want to design a building in the like Chicago or something, some area north of the American, you may consider to include the more opening windows in the southern area, especially they can get the good quality natural lighting. And for the building size, like if the building is very long, very large, that's mean in this area they can get the really good daylighting, natural lighting, but this area we have to consider use artificial lighting to make sure the people can get enough lighting energy. And also maybe you can consider like in this area we can design to storage, or like some area we don't need opening, we don't need lighting system, and this area may be very good, we can use it at the like the workspace, the people can work in this area. And here list some building shape. If you are architecture students, you may more familiar with that. So if you are interested, you can go through that. But for this class, I don't want to unfold too much. And this one, problem glare, that's very important. Whatever you are architecture engineer or construction management, so you need to know that glare is very bad for a building. So disability glare light reflects off the target and the otherwise mask reduce the contrast of the target, disabling the visual task. Like if you want to sit close to the window, especially at noon or afternoon, the daylight is very strong. So at this area and time, you want to read some words, you want to use your PC, laptop, or you want to read book, so this is very hard. This is harmful for your eye. You will feel the visual discomfort. So we can use some shading device, a curtain to avoid this problem. And a solar shading device, they have the horizontal and vertical, especially this depending on the orientation to select which types of the device for the building. Like here is some example, the after exterior shading device. And also now we have a lot of the automatically shading device. So that means they can follow the daylight direction to change the shading device direction, and then to avoid glare, and also to make sure the best or good quality natural light direct sunlight into the building. And some daylight and energy conservation. So again, like we can use automatic solar shading device to provide good quality lighting, and also to reduce artificial lighting usage. And then we can make sure the energy consumption in lighting is reduced. And then here is the energy assumption in a building. So you can find the most of that is HVAC, and the second one is lighting. So if we want to reduce lighting, if we want to design energy efficiency for a building, so we can consider how to reduce energy on HVAC system operation and lighting system. And then also we can use other like passive design, and then change orientation depending on the orientation location to design the lighting system, and also select the building material, window material, and also to choose the renewable sources to reduce non-renewable energy usage in a building. And right here, I put some example. Again, like I don't want to spend too much time on this. It's a MEP course. We already have too many maths and calculation, but if you are interested, I hope you can go through that because it's very simple. And the last one is a renewable power source. So just to get a big picture, and what is a renewable source? Like wind, hydropower, solar, very common. Like now, a lot of residential building, we use a solar like a PV panel on the top of the building, roof building, to reduce our electrical bill. And the biomass, geothermal. So this is a renewable energy source. Like especially your architecture technology students, you may inform more about that.